Good evening, everyone. Welcome to our Tuesday evening West Coast Space Show program. And I'm your host, David Livingston, and out of Las Vegas. Thank you very much for tuning in. A couple of very quick announcements before I introduce our guest. Um, we're going to talk about Artemis on Hotel Mars tomorrow morning. Bill, I hope you can join us if you got that invitation.
Okay.
And and on coming up on Friday, we're going to talk about thin film solar and its application with DOD or DOW, however you say that today, and in other applications as well in space, not necessarily military space. And then Shuber Ali, the original space Cynics generator, is back with us. And he has some really critical numbers and analysis on things like orbital mirrors, uh, power centers in space, all sorts of things. It should be a very interesting program. But tonight we're joined by author Jim Van Laak. His book, To See Far, Conflict and Cooperation on the Space Frontier, is most interesting. It documents much more than his experiences with the ISS because he was charged with putting a lot of the programs in place and the cooperation and making things happen with the former USSR. So I heartily recommend the book to you. It is on Amazon, and we're going to have an interesting discussion when you talk about lessons learned, like we want to do with Artemis, for example. I suspect that ISS and negotiating with the former Soviet Union and getting a partnership when we're all ducking and covering in schools is quite an accomplishment. Jim, welcome to the Space Show. How are you tonight? And thank you
Thank,
for being here.
thank you, David. I'm glad to be here.
Introduce us to CFAR and your work. I'm anxious to hear from you.
Okay. Well, so I'm going to kind of trace the storyline of the book. I think the prelude begins with me. Well, first of all, I was in the last class that was drafted for the war in Vietnam. I was not intending to be in the military, but I got number 7 in the draft, and I was about to serve my country. So I walked across the campus and found the ROTC, and the Air Force took me in. And although the war ended before I had to go get shot at, I was committed, and I spent 7 years as an F-106 and an A-10 pilot. And the book begins with me sitting alert at Loring Air Force Base in Caribou, Maine, on a brutally cold winter night, watching these poor young men, and I think there were women in those days, not quite certain. This is 1981. Um, Out there guarding and manning the B-52s that were on offensive alert. We were on defensive alert with the fighters, and contemplating what in the world brings the human species to put so much of our treasure into annihilating each other. What circumstances could lead an intelligent species to do that? And if somehow we decided that maybe killing each other wasn't the best thing to do, how could we possibly overcome the 40 plus years of animosity that had been built up by that point? And the that leaps into the next scene, which is when in 1993, I was one of the original 7 leaders of what's now the International Space Station. And we sat down with Dan Golden and Yuri Koptev and our Russian and American colleagues, uh, including Dave Mobley, for anybody who knows Dave, who recently passed away. Dave was a key part of helping us put the program together. And we hashed out the details of what we hoped would be a grand cooperative program. And I can tell you that it was a very tense meeting with some raised voices and disagreements. But at the end of the meeting, we all realized that we either had a joint program or we had nothing. And when you face that kind of a stark reality, it incentivizes people to to start thinking about how to work together. And of course, in the years to come, we had to evolve from that survival instinct into a genuine respect and concern for each other. And I think it's wonderful to say that we did. In fact, the third scene in the prelude is on February 1st, 2003, when the Columbia went down. And I was not working that mission. I was a customer for 22 space shuttle missions, but not that one. And I went into the control center and we recovered how we were going to keep the space station going. And I helped talk to the Russians and explain what was needed. And it's with great pride that I can tell you that they set up a memorial in their mission control center and they treated all of the Americans with respect and consideration. And they picked up the ball and they kept the space station going, which, when we first decided to work together with the Russians, there were lots of naysayers who said, they're unreliable, they have different technology and so on. One of the key reasons in favor of bringing them on board was to end up having two independent launch and logistics capabilities so that we could keep the space station going in the event that we had an interruption in either the shuttle or the Soyuz launch capability. So that's kind of the introduction. And then the rest of the book explains, a chapter about my upbringing, but then really jumps into I joined NASA right after the Space Shuttle Challenger accident. I worked on Space Station Freedom, then ISS, and then some other things.
Um, if I can jump forward with
Please.
your background and your perspective to today, are you a bit sad that ISS is going to be deorbited and gone away? Should it be saved as a monument or a museum, park it someplace, or should it be refurbished and keep that national lab going, for example? So we get all of it on this program. I hate to see us burn up that national lab. Jesus, what a treasure that is. But what are your
And
thoughts?
of course, I have the same emotional response. It's going to be very sad when it happens, but the the stresses that it sees, the risks that it presents, primarily in orbital debris, are still significant. And just designing a machine to operate for 30 years in the space environment and all the logistics required in order to sustain it was a tremendous challenge at the time. And I'm absolutely thrilled with how well the design and the teams have worked all this while, but its time will come soon, and it deserves to be retired. I mean, I think it would look great on a pylon someplace, but that's a little bit impractical.
Did we park it in a higher orbit as a museum or something, or let it burn up?
Well, the orbital debris environment gets worse until you get very high, and nobody's going to pay the price to take it. And I don't sure it would be very useful if it was at 2,000 miles or something like that.
Well, um, it is sad, and I don't think the commercial stations are going to take over the place of that station or the national lab. That's just my own thinking, and I don't know that it will be as safe or as operated as safely and have as much redundancy as what the ISS has been proven to have. In fact, I honestly don't see how the commercials, which are all sort of startups and entrepreneurial, and maybe they have gray beards coming out of the ISS and stuff, but boy, they don't have that experience and know it all. Maybe I'm just an old geezer who doesn't see the greatness of youth, but it does concern me. And I know that's not part of your book, but since you're here, I wanted to ask you about it.
Well, and the most important. So I've spent my entire life in aviation, 55 years since I was in high school. I've also lost 44 friends in accidents over that time and had a couple of really, really close calls myself, mostly in the military. And that just means that I'm not risk averse. I understand the environment in which we're operating. And the truth of the matter is, the most important characteristic for someone who wants to lead in the space business is humility. The understanding that there are so many things we don't know, and that we need to be prepared to deal with just about anything that you can imagine. And you're absolutely right that a lot of the entrepreneurs have no sensitivity to that dimension of it. And some of them, in fact, are diametrically opposed in terms of their personal characteristics, if you know what I mean.
Um, it seems to me, 'cause I'm about to be 80, that we are always going up against tough people. I don't mean tough business negotiations like you're going to pay this or that for a building and you're or a house and you're going down to the bottom line on price or terms. I mean, really bad people like we're doing right now with Iran, for example. Do we learn any lessons from what you guys did with the Soviet Union? They weren't nice. They scared the shit out of us. I was a kid, and honest to God, we were doing duck and cover drills all through kindergarten through, I guess, maybe junior high in Oklahoma. And um, and we're still, we're seems like we're doing the same patterns over and over again. So do we ever have lessons learned? Why are we in a rut to some of us?
So I guess I'm going to launch from what's in the book for just a moment to the
Okay.
larger message. Okay, so the title of the book is To See Far. And my wife, Doris Hamill, wrote a brilliant foreword that describes what we gain by going to space, which is the long view, the perspective on the universe, of course, but also on planet Earth. And in my opinion, the most important is what we learn about ourselves as a species. And, you know, the reason that humans have advanced is because we alone on this planet have a brain that allows us to anticipate the consequences of our actions and choose the path that gives us the best outcome. Well, if that's true, how do we end up with wars? How do we end up with murders and all those sorts of things? And the answer is that that brain that gives us this intellectual capacity is carried around in a biological thing called an animal. And we have instincts and we have emotions that corrupt what comes out of our intellectual process. So, the short answer, well, it's not a short answer. The core of the answer to your question, in my opinion, is that we need to learn to understand how those biologically based influences change what our intellect would have us do. Because no rational person would start a war, right? And no rational person would pollute the atmosphere and ruin our planet for human life and so on. So we have to to learn that, and it was part of the success we had with the Russians, with their realization that it was only working together. Forget the fear, forget the mistrust, forget you may or may not like our movies or our food or something. If we don't work together, we don't have a future in space. And that, by the way, was a message that was communicated to us brutally during the summer of 1993 when we went through the transition from Space Station Freedom to the new program. Bill Clinton, through his science advisor, told us that if the Russians were not part of the program, there would be no space station program. And you may recall, following the Challenger program, they took commercial payloads and military payloads off of the space shuttle. The military had a few they had to get rid of, but basically, when they were done, there was nothing for the shuttle to fly if we didn't have a space station.
Mhm.
So we had to make this work, or there would be no human spaceflight program in the United States. And the Russians, because of the condition of their economy, which was absolutely in the toilet, were similarly in a position. They either worked with us because of the money we would give them. It was not a lot of money, but they run their space program on the cheap compared to us. Uh, and it gave their government a reason to support them. There was prestige attached to this partnership. So it was a very difficult transition for everyone. But, as the title speaks to, we had a distant vision of where we wanted to be, which was still in space, still flying space, human beings in space. And the only way to get there was this path.
Were both you and the Russians, was it on the job training to be able to do this, or did you have a guidebook or role models or something to key off of in the process of doing this?
No, nothing was presented. To the best of my recollection, there were no diplomats involved, for example. There probably were some at the level of the formal treaties because the space station program is based in treaties. I mean, there's
Right.
that kind of legal language, but all of the technical partnership, we had to learn it ourselves.
What has it been like over the life of the shuttle? Has it been easy street working with all the partners, including Russia? Is it still a challenge? Are you still learning these lessons on and on and on?
Well, so I left the active management of that quite a long time ago, but I will tell you that across the 10 years that I was involved, it was a slog every day. But I will also tell you that the difficulties I encountered with my American colleagues were very nearly at the same level as the difficulties I had with my Russian colleagues. The Canadians got along with everybody. They were easy. The Europeans and the Japanese were getting along, but they hadn't, by the time when I left, they hadn't flown hardware. So, it was abstract as opposed to a concrete day to day activity. If I may, though, I'd like to share a story that's in the book that's illustrative of the learning process, because while
Okay.
nobody gave us a handbook how to do this, as I was finding my way through the forest of how to do my part of it, a couple of lessons popped out. And this particular one was in the summer of 1993. And when we were first asked to start working with the Russians, we were staying in Crystal City across the river from Washington, D.C., by the national airport. And we had a cadre of Russians in the next building over. And I went over to visit with the chief engineer of Khrunichev to talk about my personal concern, which was whether or not together our systems would work together well enough that they would be reliable over the 30-year horizon that we were talking about. And so I was introduced to him, and he was about 20 years older than I was. I was 40, and he was in his maybe mid 60s or so. Obviously unimpressed to be meeting another young, spoiled American. But I sat down and I said, I have some questions I'd like to discuss with you. I'd like to understand your view of how do we manage redundancy? How do we design our systems so that they'll fail in a predictable way? And how can your systems back up my systems and vice versa? And he gave me the strangest look. But then he jumped right into the conversation, and I pulled out a piece of paper and we started sketching system diagrams in a very crude level. And we had a marvelous hour-long discussion. At the end, we shook hands, which I'm told wasn't common. And after we left the room, I turned to the interpreter and I said, "What just happened?" He said, "What do you mean?" I said, "Look, he gave me such a strange look at the beginning of our meeting." And the interpreter laughed out loud. He said, "You treated him with respect. Most Americans go in and lecture him as if he was a child and didn't know how to build and operate spacecraft, but you treated him like a colleague." And that was one of the most productive meetings I've ever been in. And so, when you have that kind of an experience at the very beginning of our joint program, I used that as a vector on how to cooperate with people across the rest of my time in the program. And oh, by the way, it works with all human beings. If you want somebody to work with you, you treat them with respect.
novel idea. Do you believe that this perspective or culture um, is layers and layers deep in the American side of ISS associates and people involved with it, as well as in Russia today? Is this kind of how the culture is, and everyone operates and gets together? Uh, is it prevailing?
So I'm not involved day to day. I have, until
Right.
recently, I had many friends still in the program. Most of them now have retired. But I think it's safe to say, watching the events, that it has become the culture of the program. They must work together. They do work together. It's not like somebody was coming over to borrow your lawnmower. They know everything there is to know about your lawnmower and your house and what you ate for dinner yesterday. And it's like a family kind of a relationship. So I do believe it works. I do believe it's transferable, but it has to be carried by individuals. I don't think an organization can force it.
And leadership is top down or from the lower levels going up or all over the place?
Well, that's an interesting question. I believe that the culture has normalized this behavior in such a way that the leadership knows that's the world they have to work in, and so they don't fight it. They comply with it, and likewise, the people at the working level, they need to get their job done. Most young people today, I mean, I'm 72, so anybody younger than that is a young person, I guess. But people in their 20s and 30s know nothing about the Soviet Union. They have no reason to have anything but a collegial relationship with them. So I think now today it is a pretty stable thing within the program.
Marshall, you want to speak out?
Yes. Um, in my long, illustrious software engineering career, every once in a while, I would come up with the answer and I would know I had the answer, but the hard part was selling it to everyone else. And that in NASA and the whole space program, I'm quite sure that happens quite often. Some pipsqueak little software guy in a corner comes up with a solution, starts mapping it out, and they go, "Oh, wow, that I think will work." But most of the time, they just go, "How did you ever? Have you experienced it, and how did you resolve it?"
So the first time that happened, nobody wanted to pay attention to me. If so, I went to work on the Space Station Freedom program as the on-orbit maintenance manager, and you may recall the Fisher Price study that said that it was going to take 3,200 hours of EVA a year to maintain Space Station Freedom. At which point Congress said, like hell, and there was a very serious threat that the program would be shut down.
Mm-hmm.
And it was into that job that Gene Kranz, I worked for a guy named Dennis Webb, but the guy who convinced me that this was a job I wanted was Gene Kranz, just because of his stature and his, gravitas. But it was a very serious problem. As I worked through it, my job was to figure out how to get the work done. But as I worked through it, I discovered that was the attitude control function of the Space Station Freedom during assembly was an exceedingly fragile system in terms of reliability. I for me, it was by observation, but you need to do numbers in order to get people's attention.
Mm-hmm.
So I asked Atkins' first law of spacecraft design. I'm sure engineering is done with numbers, and anything that doesn't have numbers is just an opinion. So
Mm-hmm.
I went to the reliability group at JSC and said, please give me your best assessment of a numerical estimate of the reliability of the system. And so when they looked at the interval, the time during which that capability had to operate, which was, I think, about 15 months, the probability of it functioning across that time was 35%. In other words, the probability of failure was 65%.
Yeah.
Now, I thought that was a bit of a problem. And the response from the engineering teams was, well, my hardware won't fail. Yours might fail, his might fail, but mine is good. And so leave me alone. And so I was struggling with that, gradually making progress. Bob Moorhead was the program manager at the time. And I think he was probably humoring me, but he realized that I was filling an important need. And we were gradually moving towards uh, some improvement. But that was right before the redesign occurred of 1993. And when the investigation was done to decide whether or not freedom could be the basis for the new program, Bill Shepard, the astronaut, Jim Weatherby, the astronaut, um, Cheryl Depp, a number of other people were in a group that were sent off to assess the quality of the design, and my concern floated to the surface. So it wasn't that I was just in my office doing my thing. And like you said earlier, kind of in the back corner, and nobody was paying too much
Mhm.
attention. But suddenly, because of the redesign, the spotlight was shown on this concern. And so the immediate reason that I was brought into the ISS team at the beginning was Bill Shepard was made the transition program manager, and he said, fix it. We're going to fly this thing, and we want it to survive assembly. We want it to survive 30 years. That means it needs to be a robust system. And if I can reflect back for just a moment on my background here, um, I have a strong interest in physics. Classical mechanics is just in my
Mhm.
DNA, so it's very, very easy for me. But I got involved in aviation in high school, and when I was 19 years old, I had a fuel line break in an airplane and set it on fire while I was flying. And I
Mm.
managed to get it on the ground, and I got out unhurt, but the airplane burned to the ground. And being 19 years old, it had quite an emotional impact on me. And so I had one part of me said, I'm never going to get in an airplane again. But because aviation has a very strong appeal to some parts of some people, I mean, I this was what I wanted my life to be. And so I decided that I needed to understand it. The answer to fear is understanding. And so I learned what makes machinery work, and I learned what makes machinery fail. And as I went through my life and I started to lose friends in airplane accidents of all kinds, military and civilian, usually the cause of the accident was a human cause, not a machine cause, a mechanical cause.
Mhm.
And so I am very, very attuned to the errors of judgment that we all make. I've made them myself, um, and and how we need to be skeptical and curious and attuned to the quality of our decision making and open to criticism from others. And you get the general idea. That has been the focus. And by the way, the Russians had lots to say about the way we did things. Usually we didn't agree with them, but often we learned something from them. And that's what really matters.
Did they learn from you?
Absolutely. Absolutely.
So,
Not necessarily by choice, uh, but they did.
so you were a young guy, you had a family. So how did you bring what you were learning, experiencing, and stressing over into your personal and family life? Did you compartmentalize? Did you keep it separate? How do you integrate all of what you were going through and learning and experiencing and keeping your wife and family out of it, or did you blend them into it?
So I um, I guess I tried to compartmentalize it. In all honesty, my wife is an absolute saint. She is one of the smartest people I've ever met in my life, by the way, an engineer and a physicist, and just brilliant. But she saw the value of what I was doing, the value of healing our Cold War wounds, and she put up with it for basically about 10 years. And a great deal of that time, I was 80 to 90 hours a week with occasional gusts over 100. And I came home burned out, angry, frustrated. I couldn't show that at work, right? When you're in and it was a diplomatic leadership role, you cannot let your emotions be part of it.
So, but you let them be part of it when you walked in the door to the house.
I couldn't help myself. I couldn't help myself. I mean, you know, I didn't beat my wife or the kids or anything like that. I was just burned out, and they tolerated that, and I am forever in their debt.
Did you ever seek an opportunity to be an astronaut to go to the space station?
I did early in my NASA career, but I have allergies that made me medically disqualified. In order to be competitive, I would have had to go to grad school, which I was willing to do, but I was medically disqualified, so that ended it.
Marshall wants to chime in.
Yeah, I was. I've been in the situation that you were talking about, and you come home and it's kind of like you got to do something to just so you can get back to sleep, right? And my wife was, just like I'm taking care of the kids, so on like that, and you can go over and jabber all the odd stuff that you're talking about because she didn't have a clue. And this September, it's going to be 50 years. So,
Yeah, we're
um,
coming up on 51 in August, so yeah.
yeah, well, the part of being a good engineer is basically, just like you said, being diplomatic when you have to be diplomatic and knowing when you can just yell at the wall because it's important to let it go too.
Um,
Well, so by the way, the title to the book was my wife's creation. And
okay.
let me tell you that story. In 93, as we had just passed muster with the White House, so we were starting to get the ball rolling. We brought a whole bunch of teachers down to Houston and had a big event in Space Center Houston. That might have been before Space Center Houston existed, but in any event, we had a big event. And one of the teachers asked me, how do I explain to my students why it's important to go to space? And I gave an answer that I thought made sense. And then that evening at dinner, I mentioned to my wife what I had said. And she said, well, you screwed that up. And I said, okay, smarty pants, what should I have said? And she said, if you could explain to a bushman from the African veld what it means to go to space and ask him if it's worthwhile, he would say, of course, for the same reason I might climb that tree or climb that mountain to see far. And I took that new insight to work with me. And I started looking around and realized that that was exactly true. What I said earlier about looking at our own species, you know, it comes through multiple times in the book that there were lots of technical challenges, but the big challenges were humans to humans. And that's where perspective comes in.
Um, how have you seen NASA from all of these years that you've been with it evolve and change? And do you grade it or say it's done a good job in seeing far? What, because you've been with it for decades here. So
Almost 40 years.
yeah,
Yeah.
I'd love to have your assessment of how seeing far has been accomplished with NASA.
So there are people within NASA who do it brilliantly. One of the joys of my life was I spent a year working on the James Webb Space Telescope, bringing my space operations experience to help them through the launch and activation of Webb. And the astronomers, I mean, they literally see far, right? But they're scientists. They're curious. Why did this work? Why didn't that work? Pardon me. And they do very well. A great many of the others in the agency do not. And I won't use names, but I will tell you that there are people, many of whom I'm sure have been guests on your show, who are kind of like a one-trick pony. They see the solution to every problem as X, big rockets, small rockets, commercial rockets, whatever it might be. And they do not have the aperture to consider the larger picture and whether or not there's a better way to approach things. And right now in Artemis, I'm very disappointed with the lack of knowledge of history. There's so many things that are being done that are not just repeats of the past, but in many cases, repeats of things that were unsuccessful in the past. And one could wish that they would have enough knowledge of history to say, well, it didn't work 20 years ago. It's probably not going to work today.
Are you talking about like the space shuttle, like having a reusable spacecraft, and we're just doing the same thing over again with Starship? Is that the kind of thing you're talking about?
No, not so much. Let's see. One thing, for example, this may not sound exactly the same point, but a group of people think that, well, we landed on the moon 55 years ago, we can do it again. We'll just go do it. It's as if we kept the rocket parked in the garage and would just dust it off and off we go. Well, the technology is altogether different. I mean, the machinery is different and the people are different. The operations are different. Artemis 3, the baseline program, I was highly critical of because it did not follow the flight test protocols of the past. The Artemis 1 was unmanned. Artemis 2 was what we just did, the circumlunar flight. Artemis 3 was to land on the moon. The first time humans would ever be in the Starship would be when they undocked to land on the moon. And there's a long list of details that I can't go into because of the proprietary nature of these commercial service contracts, but they are, it's as if they're trying to bring science fiction movies to life as opposed to doing the hard engineering, explaining, exactly what we know and what we don't know and how we do verification that the systems are going to work. It's a very detailed conversation and a little bit sensitive, but do you get the idea?
Yeah, I think I do. I mean, I've also, being an engineer, I've also looked at a lot of these solutions, and I have to scratch my head as to what's really going on. I feel like the way we're deciding things is more done by kind of the committee nature of the problem. So like trying to get a lot of people to agree on something results in a solution the first solution that everybody agrees will work, not the best solution from an engineering perspective. And I feel like I was going to ask you about this earlier, actually, there's like a cost to the program, to the taxpayers, to society for not doing the most optimal engineering solution, and for not being able to align our societies, our contractors, our private sector and our public sector agencies around the best possible solution. And that cost is enormous. I have no doubt about it. I mean, if you ever watched the TV show Pluribus, where there's like a hive mind for the entire society and everybody is doing exactly the right thing all the time. Like if you compare our current society to how that society would probably approach the space program, I feel like there must be at least a tenfold increase in cost or decrease in efficiency, right, related to the way we're doing it. And I wonder if there's been any effort to really measure that, to say, like we're not doing the most optimal thing because we're not cooperating in enough detail. So how do we fix that so we end up saving a lot of money? Have you ever studied that or thought about that?
Absolutely, a great deal. And I don't want to get too specific to be critical of specific people, but I'll tell you that the the core, just so let me begin by admitting that when I was a young person, I was very shy, had very low self-esteem, very low expectations. And it would never have occurred to me to apply the word leader or leadership to myself. But as it turns out, that what I said earlier about understanding, learning, studying how systems work, how they fail, how people work, how people fail, put me in a position to have an understanding of the problems that my colleagues didn't have. And so my ability to articulate not only the problem, but what the solution space was, suddenly put me in a role where people said, well, what should we do? And I could answer that question. So the problem with NASA today is poor leadership. And by that, I'm not necessarily throwing rocks at the current leadership, but talk about the last 15 years and or more. And, having someone who has the global perspective of what we need to do and why. So, for example, something that's had the agency tied in knots for the last few years is handling the issue of flammability in the cabin when you're trying to come up with an atmosphere that lets you not get the bends when you send people EVA. It's,
Right.
they call it exploration atmosphere. And, there's a trade space there that's perfectly logical to go after if you have experience across the whole problem. But we don't. We have people who are experts in combustion. We have experts in, the bends. We have experts in materials and so on. But very few people who understand the gains. If you think of it as a a machine that you can adjust the gains of the control loop, they don't understand how that works. And when that leadership is present, as it was in Apollo, and I would like to say as it was in much of ISS, we were able to converge rapidly to the issues and the range of gain values that we had to play with. And once you get in the ballpark, it's not hard to just keep, just I'll accept that for now, we'll tune it later and move on. But when people are trying to optimize everything, they just, the system locks up because you can't, you end up with singularities, right? That you just can't get past.
But is there like a more fundamental sociological reason, like some sort of weight, something you could measure that says this group of agencies and their leaders are not achieving an optimal output because of some metric that could be measured, like interpersonal relationship skills or ability to cooperate or ability to listen or whatever. Like there's got to be a reason that you could measure that you can say, hey, that's why we're not getting there.
So, do any of you folks know Gentry Lee from JPL? I
No,
I've
don't see
heard the
the.
name. Yeah.
So Gentry, I hope he's still alive. I honestly don't know, but he was a systems engineer and very energetic, brilliant, outspoken character. I didn't know him well, but I got to watch him in operation. And his description of a systems engineer is someone who understands the first derivative of everything with respect to everything else. And so that is the most important thing. And when I say everything, I mean the human dimension as well as the technical dimension is what we need. It is extremely rare. If you think about it, NASA has fantastic capability because it is an enormous pool of brilliant experts. But those people became brilliant experts by zeroing in on their expertise, whether it is, non-metallic materials or, the effect of oxygen bubbles on, infections in the body or whatever it might be. And but having all that expertise is worthless if you can't figure out how to stitch it together in a way that they complement each other, that they converge on useful answers. And so, my perspective, it's a self-serving, I guess, since I feel this is my talent. The thing that's missing is somebody who can say, okay, I understand what you've got to offer. We've met your top five things. Now, please have a seat and let's hear what the next person needs and work that out. Instead, everybody creates a big working group and they go off and they spend 5 years, you know, studying how to optimize their dimension of the problem, even when it becomes independent or in conflict with other parts of the solution space.
Uh,
Um,
Go ahead, Marshall, and then I'll
uh,
go.
yes, that comes in and almost begs for your opinion of how Elon Musk is running SpaceX, because he is a step above those systems people that can do the first derivative of everything, and and he still pushes them to do spectacular stuff, and he can keep his cool when it blows up.
He can. I only had one interaction with the gentleman by email one time, and it was not pretty. So I would I can't comment on him. And to be honest, I don't think he's really running SpaceX. Gwen Shotwell's the president, but the technical team has established enough
Mm-hmm.
gravitas that I think that they are, Elon has established a goal that they're after, and the
Yeah.
team is doing their best to get there. Now, whether or
Yeah.
not they can get there, I am skeptical because basically, in my opinion, the Starship is a repudiation of the rocket equation, and yet the rocket equation is still the law of the land. So, the penalties that they are paying in order to try to implement that are very, very steep.
Yeah. But it does come in there, and being able to pick people and put them into place, that's true management. And that's always fascinated me because at best I was just a systems guy, this piece of software, that piece of software, making, putting it together, et cetera, et cetera. And then, you know, writing code to find the bugs, which was my last major job. Uh, and being able to pick the right people and getting them in the right place is a terribly hard problem. And you've risen up through the ranks, so you at least have lived through it. I don't know if you've actually been a picker, uh, a mentor to other people.
Well, so I'll tell you, and then I know David wants to say something, but most of the people that worked for me, and I had, a couple thousand people in the ops program in the space station era. The chairman of the MMT, the head of the operations program, ran everything that wasn't building hardware. And Tommy Holloway, the program manager at the time, washed his hands of what I was doing, which is all described in the book. And but those people were self-selecting people. They knew what they wanted to do. They knew what they wanted to be, and they were the experts. They were the wonderful first baseman, second baseman, outfielders. My job was to be the coach. My job was to be the team captain and to keep them working together. And it was a brilliantly capable team. I was blessed beyond words. But again, back to the point about leadership, they were looking for a leader. They were looking for an answer. And on multiple occasions in the book, I talk about a serious technical problem that came forward, and I led the team through discussions. And in the end, the decision was mine. You do poll, but in the end, unless it's unanimous, the decision is the chair, or was in those
Mhm.
days. But as soon as the decision was made, they walked out of the room to execute. There was no audible, bickering or anything of the sort. They said, okay, we got our marching orders, we'll go do it. And it was a tremendous honor to have that role.
Mhm.
So I know we're coming close to the hour, unless we go over it a little bit. But it seems to me that there are a lot of external constraints on NASA. There were back in your day, and there are today. And I don't think the people are quite the same that exercise these constraints. So I'm mostly thinking about Congress, for example. So I will not embarrass you to tell me how many members of Congress, in your opinion, can see far. But I will say that in my opinion, you might count them on one hand, maybe two hands. If you're really generous, you can add a couple of toes. Not very many, yet it's their oversight and their constraints and their votes that create a rocket like SLS, for example, that create all sorts of different things uh, that are going on that NASA has to sort of hiss up to because they control the funding. And so today they want to cut 50% of the science budget. Whether that will happen or not, I'm a believer in science and would not want to see that budget cut. But that's a horrible constraint that works against everything the way I understand seeing far is supposed to be about. So, and I don't know how to avoid it or to deal with it. And I don't believe the general public knows what we're talking about. Not because they're not listening to this show, but just in general. So it's a hell of a position to be in when seeing far is probably more crucial today than it was back in those days. Although, we were scared that we were all going to blow each other up with H bombs.
Yeah,
So
that was an important
that's
vision
a
to have.
consideration, yeah.
Yeah.
And I don't think most people think that's likely to happen today, but there might be other really bad things that people are worried about. How do you cope with the constraints that limit what you're talking about and the successes that you're telling us about?
So first, I'm fine to go past the hour if you are.
Okay.
I'm fully engaged. I'm not falling asleep, so that's great. Um, the answer to your question um, could be long and complicated, but I'm going to use another example from the book because it is very valuable. First, the setup is that in the summer of '93, when we were going through the transition from Freedom to the new program, the fact that the level one requirements had been reset to zero or nearly opened the door for all kinds of characters to come in and demand things from the program, regardless of what they cost or what the impacts would be to other users of the station. And so we were in a constant churn of 1 week we would fly solar inertial and get rid of the alpha joints. And another time we would do something else and so on and so forth. And these variations they created an enormous amount of negative work. We were wasting our time. And so what I was able to finally get done was a creation of a decision tree that said, okay, we do have a set of level one requirements. The technical decisions that will fulfill them are not arbitrary. They are interconnected by physics. So let's use the physics to define how we can get to where we're going. That works. That worked extremely well for us. We were able to converge the chaos into a design in about 6 weeks. And that is light speed on the scale of what we were doing. And a woman by the name of Brenda Ward gets credit for having done much of that work. She led a small team. Similarly, Artemis is suffering from the fact that that has not been done.
Right.
And so there's all these ridiculous tangents being followed when they could easily converge. But to really get to your question about Congress and how do they participate in all of this, I think the right way to think about it is that they have a lot of different um, areas that they have to deal with, constituent services, and most of them are not technical people, so they're looking to NASA to guide them. And SLS, for example, is the product of NASA people who wanted to continue in the vein of how the Saturn V was built and operated. And in 1961, there was no alternative. NASA had to build a heavy lift launcher. You couldn't go buy one. In 2026, we have options for launch vehicles. They're not the size of the SLS, but we have technology. We can modularize our vehicles and do other things to accomplish the same thing without having to invest $3 billion a year in the production and operation of a vehicle that nobody else in the universe will use except NASA. And so, you know, if NASA were effective in, first of all, they need to understand that. And remember what I said about all the experts in NASA. They don't think in those terms. They think in terms of currents and molecules and structural loads. But if NASA could articulate that effectively, I think Congress would say, sure, as long as the people in my district get a fair piece of it, sure, we'll go do that. So, it's kind of, you have to be the devil's advocate and still keep it moving.
So basically, you're saying it probably starts with NASA, not with Congress.
Yes, because they have no idea how hard it is to land on the moon or to land on Mars or to take pictures in the infrared, like JWST does. No
So
idea at
James,
all.
you said that you thought Starship was a repudiation of the rocket equation, which I kind of agree with you on that because I've done some numbers myself. But I would like to hear your like what analysis you did to arrive at that conclusion, or maybe how you would explain it to the audience a bit better.
So, I mean, as we know, the rocket equation is a simple ratio. I mean, it's numbers, but in the bottom line, it tells you what fraction of the mass of your launch vehicle is going to get burned up in order to take what remains to a specific velocity, but it works out to the same thing. And Starship is just this gigantic big rocket. If you look at Apollo, Apollo was a brilliant solution of the rocket equation. Um, uh, what's the name of the guy who came up with the lunar orbit rendezvous? John Hubble was a Langley engineer, couldn't get anybody to pay attention to him. Like what Marshall said earlier, he was jumping up and down the back corner. Nobody listened to him. So he wrote to the head of human spaceflight at headquarters and said, "Boss, you ain't going to get there unless you do this." And people made fun of him, but he was right. That's why, the lunar module goes, the CSM, the command service module, stayed in orbit. The lunar module went down, and only the ascent stage came back, and then it got thrown away. You look at that 7 million pound vehicle sitting on the launch pad, and what, you get 20,000 pounds back. But that's the rocket equation in operation.
Are you
And
saying like with Starship that the basically what you get into orbit when you count the dry mass of the upper stage and the propellant it needs to land and the say 100 tons of payload that they're claiming they can take up, that's too much mass in orbit given the mass in
they're
the pad?
they're taking, and so turn it around this way. They're putting 100 tons on the lunar surface that don't need to be there. And so 100 tons times the factor of 20, which is a good rule of thumb for a lunar type mission. I mean, I don't know it. It's probably 25 or
That's the,
18 or
the
something. But
mass ratio. I mean, when you say the factor,
yeah,
do you
the
mean the
mass
mass ratio?
ratio, in order to get the delta V, is going to be somewhere in the range of 20 or even more. And so you put 100 tons on the surface that you don't need, you're paying an enormous price in complexity and operations and risk in order to do that.
I guess you're saying you'd be putting 20 times 100 tons on the pad, but it seems like
Over
they have,
20 launches, yeah.
yeah.
Yeah, I always thought that bringing that SpaceX Starship into the lunar lander program was a big mistake. They should have built a customized lander, sort of like what they had with Apollo. But I think it was a political thing more than anything else at the time that was made. And we're kind of stuck with it, I guess, for now, unless somebody else, the Blue Origin, can come up with a better alternative and do it in time. And here we are this close to wanting to do the mission. We're still trying to come up with a lander.
Well, and one of the biggest problems here is the fact that at the same time as we're talking about the rocket equation, there's another first principle of physics here, which has to do with reliability. And, again, Apollo did so many things very, very well. They did, it wasn't perfect, but if you look at the ascent engine for the lunar module, it had 4 active valves, 2 isolation valves, one each for the 2 different propellants, and 2 on-off valves. There were some check valves and stuff, but they were not active in the same way. That's it. No gimbals, no turbo pumps. It was pressure fed. The RCS did all the control of the vehicle, and so the RCS system was built robustly to do that. Now you compare that to either of the 2 HLS contractors, both of which use cryogenic pump-fed engines with turbo machinery, gimbaling systems, hydraulic systems, all of that stuff. It is probably 2 orders of magnitude more complexity than what the lunar module had. Now, obviously they believe they can master that and achieve an acceptable level of reliability, and I hope that they're right. But given a choice between a simple system that I know is going to be reliable and a very complex system that I'm going to have to sweat bullets over its reliability, I know what I would choose.
Do you think that there's people in NASA who have a complete, absolute understanding of how Starship works and are capable of signing off on the performance claims and the reliability claims? That you don't think there's people like that are really tied in, looped in?
For a very good reason. And that is that they made this decision to buy a commercial service. And so the contractors keep proprietary a great deal of the information. NASA has negotiated what they call insight, which, that means that a certain cadre of NASA people are allowed to participate, be present for technical discussions. And in some rare cases, when NASA has unique technical skills, they can actually participate in the work. But if you compare that to the level of absolute mastery that NASA has held in previous generations of vehicles and systems, there is no comparison. So Gene Kranz famously came up with the motto for mission operations. It was flight operations in his day, and of course it's flight operations now. But when I was working for him, we were mission operations. And the motto that he came up with, and the story, and forgive me, you all probably know this, but when the Apollo pad fire happened, the entire program was devastated, and the flight operations team was feeling really bad that they hadn't seen this coming, right? We all feel survivor's guilt, sort of a thing. And Krantz got them all in the conference room in Building 30, and he said, guys, because they were all men, I guess there was one woman in the room, but, he said, folks, we failed. We failed the crew and we failed the American people because we knew that was a flammable atmosphere in there, and we knew there were some flammable materials, and we didn't do anything about it. So the motto became tough and competent. Tough means we will take any consequences for doing the right thing. And competent means we will know everything there is to know about our part of the business, about the business, period. As a whole, the operations team understands the systems brilliantly, brilliantly. Well, that only works if you have access to the information. When you have commercial contractors and you're not allowed to have that information, you have to compartmentalize your understanding and just hope that they've got the rest of it right. And I am deeply, deeply concerned about that. It might work, but it's not what we've done in the past. And I am not aware of any way to calibrate the quality of that capability, that approach.
Do you think that something like I don't think the public is aware of the fact that NASA doesn't understand. They don't have the CAD drawings for Starship, but they don't have the mass of the upper stage or the lower stage or the performance of the engines and stuff like that. If they don't have this information, then there's no way they can validate anything. And then the whole architecture is based on a promise that they don't know if it's right or not. And how do we change that? Like how could you go into NASA and say, like, this is wrong? NASA needs to understand all this information. They need to be able to sign off on it. Otherwise, they should be redirecting their money into something else that will work.
Well, unfortunately, even within the NASA community, there are lots of people who don't grasp the significance of what I said and what you just said. Um, there are advocates for commercialization who have a simple model in their head that commercial guys are smarter than NASA people. They're, very efficient. They can make money doing these things. They're really good at it. They're incentivized, right? Our free market system rewards people for being successful, but our free market system also destroys people who are unsuccessful, right? And so it's just like evolution. The ones that survive, they're great. The ones that didn't make it, well, they're gone. And we are at a point where we have artificially made a decision that is not supported by any historical basis in this domain, and we will find out. My most my clearest answer to the question, what do I feel about SpaceX and their approach is, I am glad that Elon Musk has the money, the resources, and the willingness to try. But it's an experiment. And whether or not it's going to be successful will only be known at the end of the movie. And, we're not even close to intermission yet. So we don't have any idea what the outcome of the movie is going to be.
Well,
Yeah, that's
SpaceX
good
is
one.
pretty successful in terms of the Falcon 9 rocket as a Earth orbit system, right? I mean, I'd say that is a success.
They are. And it's a very conventional rocket, right? And the breakthrough that they did was reusing it. And I salute them for that. They made a very substantial advance and they made it work. But they have matured it into a stable configuration that they fly over and over again. And that's very different than saying, what the hell, let's go do this crazy thing and see what happens. So they're two very, very different programs with different philosophies.
Well, I wasn't trying to trash SpaceX in general. I was just simply saying for the purpose of a lunar lander, I think it's the wrong solution. For
I agree.
a big Earth to orbit system to put up large payloads and maybe build a new space station after the ISS is gone or any number of other things, a lot of Starlink satellites, that's a whole different subject.
Well, the brilliance about engineering is
Mhm.
that it all traces together logically.
Mhm.
And so there's no way an engineering solution would arrive at a Starship. Just isn't going to happen. Starship looks like Starship because Elon Musk wanted something that looked like a Buck Rogers spaceship. And,
Yeah.
he hired a bunch of guys and said, go do it. And they're doing their best to make it happen. But if you do it by the hard nuts and bolts of the mission, you're going to be a whole lot closer to Apollo than you would be to Starship.
Marshall, go for it.
Yeah. One of the things that I worked on was AutoCAD and basically coming in there, designing something literally in numbers, and then testing it and putting parts together, et cetera, et cetera. In fact, you could actually walk through houses and things like that. How much is that permeated NASA and improved the performance of your engineers?
Well, so I don't encounter that very much in my current role. But I will tell you that about 10 years ago, I was involved, and I cannot remember, the buzzwords were like virtual engineering or something like that. I can't quite
Mhm.
recall. And, as a tool, it's fine. But if you try to attribute more fidelity and, you know, concrete proof to it than it deserves, you're in trouble. When I am a person who tries to learn from other people. And one day when I was in Houston, I sucked up the courage and I called one of my absolute heroes, Chris Kraft. And I said, "Sir, could I pick your brain?" And his exact words to me were, "Name the day and I'll be there with bells on." He was so grateful to have somebody who really wanted to understand his life experience and what it meant. And in the course of the 8 hours, I saw him a number of times, but that day was an 8 hour day from his early experiences through, John Glenn's heat shield through the space shuttle era. And in part of that conversation, he said, "Well, I like the fact that you're a traditional systems engineer." And I never claimed to be a systems engineer. He's just that, he could tell from the way I looked at the problem. And I said, "Sir, you just told me something and I don't know what you told me. What does it mean to be a traditional systems engineer?" And he pointed out that the 90s was the era, in my experience, I could be wrong, but my experience was when systems engineering was seen as a component of the information technology domain, and they started reducing things down to interfaces and different kinds of documents as opposed to, you know, hard technical requirements, component testing, integrated testing, real emphasis on verification, which I understand software is different than hardware, and I'm not a software guy, so I can't speak about that. But when I went to, so I'm an alumnus of RPI, Rensselaer Polytechnic, and they invited me up to talk to the engineering um, team one time, and I, had an hour and a half or something with them, and one of them at the end asked, "If there's something that's missing from our curriculum here, what would you choose? What are we not doing well?" And I said, "Systems engineering." And one of them said, "Well, that's just bookkeeping." So that traces to that vision, which is absolutely false, but it is people who don't understand something, creating an image and then clinging to it regardless of the facts. I didn't probably answer your question very well, but it's
I wanted to see if you might be interested in writing a review for something called the Evidence Ledger, where we talk about Starship and some of the claims that are associated with Starship. You can go in there and read a claim that's designed to support Starship, and then put your findings, like as an engineer, you say, "I disagree" or "I agree with aspects of this claim," and then everybody can see it. It's publicly information. It's online.
yeah, I'd be happy to do that. Of course, I have to keep proprietary information out of it, but that's actually easy. Things are changing so rapidly now, and I'm backing out because I
Mhm.
just don't want to be part of it anymore. So yeah,
Yeah.
be happy to.
So
I'll throw a link in the box.
let me take you to maybe it'll end up being the concluding question. I don't know. But so let's assume I'm 60 years younger, a 20-year-old guy, and I'm browsing books in Barnes and Noble. and you're there for a book signing, and I see your book on the table, and I understand that you're the author, and I say, why in the hell are we doing this? What's the purpose? Why do we need to be on the moon? Why are we spending all this money? The age-old questions that everybody in the space age business knows get asked all the time. How do you respond to this 20-year-old kid as to why you think space is important, is useful, we're spending the money on it, why we should do any of it? Is it all about diversity? So we have a diverse crew going to the moon. Is that the biggest part of it? Um, Answer it. I'd love to hear your response.
So my answer is what my wife said brilliantly in 5 pages. I'd say it in a sentence or two, which is that, and nowhere near so eloquently as she did, but the nature of the space enterprise requires the highest performance we can possibly achieve. And in reaching toward that goal of being good, of being efficient, of being right, we advance ourselves and our society. We make the world better. We develop technology that protects us from natural disasters and enhances medicine and improves cognition and so on and so forth. That's what happens when you reach for something that is just barely within your reach.
And aren't there things to reach for here on Earth that are more practical than trying to go to space?
There are alternatives to this, but unfortunately, humans uh, have not found them inspiring. Right? In classical times, going to war was probably the closest equivalent to it. You know, knights got all duded up in their armor and they became heroes and became wealthy. They received gifts from the king and all that sort of thing. It was a way to get ahead. Well, that's not really very helpful to the serfs or the rest of the society. Um, Inherently, space is constructive. It's expensive, but it's constructive. And, that's, I guess, the best I can do for an answer.
Anyone want to comment on that or something else?
Uh, I'll take a quick shot at it. And I think I said this last week. I say it quite often. 400 years after the first baby is born in space, there'll be more people in space than on Earth. And maybe about 500 years after the first baby is born in space, there may be a trillion people living in the Goldilocks zone. And everything that we do now to further that along is just going to enhance the humans as a species and as an intellectual thought. And just like you said before, we're going to see of extremely long view. Even the James Webb Telescope is going to be replaced with something so big and so wonderful that we're going to be taking pictures of the Big Bang.
But if I may, and I don't disagree with the point you were trying to make, but I like to point people to one of those intellects that I wish I could have met, and I'm talking about Ray Bradbury. If you remember his book, The Martian Chronicles, at the end of the book, after settling on Mars, a war begins on Earth, and almost everybody goes back to Earth to die with their families. And the meaning of that is that the future of the human species is in the human species. Elon says, I want to be a multiplanetary species. Well, that's irrelevant in the big picture. Or let me rephrase that. It's going to be a long time before it's meaningful. we're much more likely to destroy ourselves with a new organism or a nuclear weapon or whatever, or just have our society disintegrate into tribal, groups pounding each other, than we are be taken out by an asteroid. So, you know, we when I talk about the long view of space, the long view of looking back on ourselves as a species is a big part of it. And again, not to plug the book, but when you read the book and you see the immature, partisan, childish things that so many people did on both sides of the ocean. By no means am I pointing at the Russians. The Americans did it every bit as much. Um, that should be a wake up call to say we need to grow up as a species, but as individuals as well.
Mhm.
Do you see like if we want to have a McMurdo style base on the moon, like people go in there regularly doing research, those kinds of numbers. Do you see this overlooking an important technology that we would need if we're going to achieve that kind of scale of a base?
You mean, did the current plans ignore something?
Yeah, like are we not like I imagine we would need some advancement in transportation technology or something that we're not capable of doing because if we don't advance in some way, it's going to be too expensive. So
So you saw the ignition event that the administrator had a few weeks ago that talked about the Mars colony and all that business. It was um, a credible vision in terms of its content, but the schedule was, nonsensical. And finding the support to build nuclear power plants for lunar applications, for example, is not a trivial thing. The cost, the social issues attached to launching large amounts of fissionable material into space and so on, those are major issues that aren't going to be
but
taken care of.
at least that one's not overlooked. I mean, I think they could say it's underestimated, but it's not an
Yeah,
overlooked
I don't
technology.
think anything's been overlooked.
Okay.
Although I'm always curious why one group of doctors think that radiation is a lethal threat and another group thinks that it's not. I can't see how those two points of view coexist.
What about just the cost of rockets? Like, how do we how do we maintain a base of that scale with the rockets costs being what they are?
Well, for as long as I've been involved in the space program, we've been going to lower the cost by an order of magnitude within the next 5 years. So, every 5 years, it's going to cost 10% as much. So,
How long have you been in the
the
space program for?
the model of the Falcon 9 is a good model, right? If that could be replicated on a scale that supported, translunar shipments, and I'm sure that it could with the Falcon 9 Heavy, for example, um, the cost would drop. But how you turn that into a commercially viable activity that pays for itself, I can't answer that question. I don't have a vision. People talk about helium-3 and all sorts of things, and I just don't get it. So,
And before you go, are you optimistic that one day we will see VAR and CET out there?
so, personally, I am doubtful that the human society as we know it, is going to survive 50 years. And Stephen Hawking had the same vision for a slightly different reason. And anytime you find yourself in agreement with Stephen Hawking, it's probably an indicator that there's some first principle involved. Um, as a human being, as a parent, I want to be optimistic. But as I look at the behavior of the human species today, and I look at the power that our technology is granting to individuals and our society today, it's difficult to be optimistic.
So do you think there is other life out there, or when we do ourselves in, like you think it's all over with?
Well, so the evolution of life, in my opinion, is a universal trend. And on the scale of the universe, I do have confidence there are other forms of life. At what level of sophistication and intelligence, I have no clue. But as you know, the dimensions in time and space and quantity of opportunities are beyond my comprehension. So I'm confident such things exist out there, but I also understand or believe that what we observe in the evolution of the human species on this planet is probably close to a universal constant because of the physics of the, so to speak, of reward and so on. And most intelligent species will probably destroy themselves, just like civilizations on our planet have done it in the past. Only now we might actually destroy ourselves instead of just having Rome collapse. We may wipe ourselves out. I don't mean to end on a pessimistic note. My point is that this is a very serious issue that I believe we need to attack. And I have a plan, I have a proposal for how to attack the problem if I could just find people with the energy and the resources to do it. I found lots of technical people who agree with my approach, but they don't have any money. And when I talk to people who have money, they don't understand the approach. You know, it's one of those catch-22s.
Is it a space show proposal topic?
Let me send you a paper and you can decide.
I would appreciate that,
I will do it.
because I don't know that I have a 50-year timeline, but I did not ask you, and I have no solution for it, is the constraint of media in education today, which is, to me, is really out of control. And I have no solution for how to bring it in. It runs so deep, and the result of it are people that you kind of can't work with. So this to me is one of the hugest problems, and it's really lousy grammar, one of the worst problems that humanity faces, and that could expedite your 50-year timeline.
Well, so let me take 3 minutes and give you the high points of my challenge, and then I will send you the paper that explains my response to the challenge.
Thank you.
And the high points begin with the fact that human society is a system. My definition of a system is a set of functional elements that work together. They weren't necessarily designed to work together. Society evolved, randomly, but it is an exceedingly sophisticated, complex system. All systems have control laws that keep their performance within certain boundaries. In society, it is literally laws, policies, insurance companies, all that kind of stuff. Well, technology has put so much energy into human society now that our old control laws don't work anymore. And so the idea that we have laws that say that you can wear any kind of a weapon you want and go into a public place probably is going to run into a problem if anybody ends up with a nuclear weapon in their briefcase. So I'm being a little silly with the example, but the problem is that we are democratizing power, and many people are not responsible enough to control that power. And we as a society need to figure out how to work with that.
Absolutely want to see your paper, and also find it interesting. I don't usually make this comment on a space show program, but and for the advisory board listening and for archive people, I have all sorts of papers that I printed out that Jim and his publicity agent sent me about his book and about the show, and some of it we followed, and some of it's been pretty freewheeling. And So I have an idea of what the book is about, and I've been able to go through parts of it, because it's what, 370 pages or something like that, 350 pages. And so I don't really have a script for a space show program, and I don't really set out sort of an objective of where I'm going to start and where I want to end up. I mean, that's a mystery to me. I did ask you where you would like to start. And so we generally start, tell us about your book and what you do. Um, and it's interesting that we end up here, which was probably a trillion miles away from anything in my consciousness. And you tell me you have a proposal. So I find it a big mystery of the universe to how we can start way over here without an objective of where I'm going for, except for you to tell us about your work and your book. And we end up with this kind of societal issue in your proposal. I don't know what the process is that enables that path to be taken. I wish I could understand it, and I doubt that anyone here can explain it to me. I don't know how it works, but whenever it happens and we go from here to here, it's a mystery to me. And it's probably not what you thought you were going to get as a question about your book presentation either.
Actually, I end up in the same place almost every time. So I guess I'm just stuck in a rut. But
Well, or if you're trying to get your proposal out there, but I was not aware of your proposal, so that wasn't in any of my talking points. So fascinating. I'm definitely interested in seeing it. And I know Phil mentioned in the chat that he would like to see it. Can I send it to him as well when you send it to me?
happy to, happy to.
Okay. And I hope we get a chance to talk again. It's a fascinating discussion, and I like talking about something other than the sides of engines and, you know, whatever technical engineering thing might be the question of the day. But thank you for being with us, and I'm really glad to meet you, and I hope we get to do it again.
All right. Thank you, David. Thank you.
How old are your children, by the way?
41 and 45.
So that's about the age of my kids. Do they think deep like you do, or are they into their own worlds?
They're both very smart, but their intelligence is applied to their interests. My daughter is a teacher of foreign students, and my son is a programmer.
So that's like my kids are in the film industry, so that's where their intelligence goes. And then I I leave them when I get off into these subjects and things like that. I think that's too bad, but I think there's a lot to be said for Renaissance people. So in broad educations, but I had a liberal arts education, and I still think that maybe hurts. So thank you again, Jim.
All right. Thank you
John
all.
and Phil and Marshall, thank you all too. Everybody have a great week. Keep looking up. Goodbye
Thank you.
from the space show.